Level 0. Astronomers thought the telescope was broken. Point it at an empty-looking patch of sky, run the exposure long enough to catch a few thousand galaxies, and the count comes back in the dozens. That's what happened in the 1970s, and the first instinct was equipment failure because nothing else made sense at the time. It wasn't broken. It had found a hole. Not an empty hole, though. A cosmic void is a region where galaxies exist at a fraction of the normal density, sometimes 10 times sparser than everywhere else, but never truly zero. Picture the universe as a sponge where galaxies cluster along the walls, the filaments, the soapy film of the structure, and voids are simply what's left in between. The 1978 CFA Redshift survey mapped thousands of galaxies in 3 dimensions for the first time, and the data came back looking less like a scatter of stars and more like a honeycomb. Sheets and strings wrapped around enormous hollow chambers. Roughly 40% of the universe's volume sits inside gaps like this, holding only about 15% of its matter. But calling every one of these gaps the same thing is where most explanations stop, and where the real story actually starts. This generic version, just a void, isn't even a formal classification yet. It's the baseline every stranger name on this list branches away from. Voids come in sizes, shapes, and origins different enough that astronomers gave each specific category its own name, and the smallest one barely counts as impressive at all. But a void isn't a category yet. It's just the word before the real names start. Level 1. A mini-void is the smallest classified member of the family, typically only a few tens of millions of light-years across, small enough that it can sit entirely inside the shadow of a single large galaxy cluster. It's the void equivalent of a pothole. Real, measurable, scientifically cataloged, but nowhere near dramatic. They matter anyway, and not for their size. Mini-voids form early and often, seeded by the same tiny density fluctuations left over from the universe's first fraction of a second. Surveys have cataloged thousands of them, dotted through every supercluster we've mapped, and they're the most common void type in the observable universe by sheer count. They're also, in a sense, unstable. Many voids sit close enough to dense structure that gravity from nearby clusters constantly tugs at their edges, and many get absorbed into larger neighboring voids over billions of years rather than surviving as distinct features. A mini-void, in other words, is often just a stage, not a destination. Void-finding surveys built from galaxy redshift catalogs, the same kind of data that revealed the Bootes void, routinely turn up dozens of mini-voids in a single slice of sky, tucked between the larger structures that get all the attention. They rarely make headlines, and most professional astronomers wouldn't call one impressive on its own. But collectively, they may account for more of the universe's total emptiness by number than every other category combined. So if this is what a void looks like near the start of its life, what does one look like once it's had time to grow into its own neighborhood? Level 2. We don't have to imagine one. There's a void with a name sitting directly against our own galactic backyard, called simply the local void. Unlike the categories on either side of it, this one isn't a class holding thousands of cataloged examples. It's a single specific address, first mapped in detail by astronomer Brent Tully and collaborators, stretching across roughly 150 to 200 million light-years, positioned immediately adjacent to the local group, the small cluster of galaxies that includes the Milky Way and Andromeda. What should feel strange is where we sit relative to it. We're not floating comfortably in its center. We're sitting right on its edge, close enough that its emptiness is measurably pushing on us. Galaxies, including our own, feel a gentle gravitational push away from under-dense regions like this one, part of what researchers call the bulk flow of galaxies across large scales, alongside a simultaneous gravitational pull toward denser regions such as the Virgo cluster and the more distant Great Attractor. We are being nudged right now by a hole in the universe we happen to live beside. Estimates of this bulk flow motion put our local patch of galaxies moving at somewhere around 600 kilometers per second, relative to the cosmic microwave background, a combination of the local void's push and the pull from denser structure elsewhere. Not fast enough to notice in a human lifetime. Fast enough that astronomers had to build an entirely separate explanation for it. And that's just a regional void, modest by cosmic standards. The next category throws that modesty out entirely. Level 3. A supervoid is defined simply by scale. Any void stretching beyond roughly 300 million light-years, large enough to swallow smaller categories whole. The Bootes void, discovered in 1981 by astronomers charting galaxies in that constellation, is the flagship example, spanning 330 million light-years and holding only a fraction of the galaxies a region that size should contain. One of its discoverers joked that, If you'd pointed a big enough telescope there before anyone understood what they were looking at, you might have concluded the universe simply didn't extend that far. Later surveys found more galaxies scattered inside it than first thought. So, empty oversells it, but even corrected, it remains one of the largest underdense regions ever confirmed. A civilization evolving near its center would inherit a night sky nearly starless beyond their own galaxy for their entire history, an entire understanding of the cosmos delayed by nothing more than an accident of address. Supervoids prove that emptiness can scale up almost indefinitely, but size alone isn't the most important thing separating one void from another. What matters more is what's sitting around it. Level 4. Most explanations skip this distinction entirely, and it's the one that actually matters. Cosmologists classify some voids as compensated, meaning the missing mass at the center is balanced out by a denser shell of galaxies wrapped around its edge, like a dent in the cosmic density field that's been fully paid for by a thicker rim surrounding it. Picture pressing your thumb into dough. The dough doesn't vanish. It gets pushed outward and piles up around the dent. That's a compensated void in miniature. Matter didn't disappear from that region of the universe, it got shoved outward during billions of years of structure formation, piling into the walls that now enclose the gap. This matters because compensated voids are, in a sense, gravitationally honest. Averaged over a large enough sphere, including the dense rim, the density comes out close to the cosmic mean. The book's balance locally. It's tidy, predictable, exactly what standard cosmological models expect to find. The book's balance. Nothing looks broken, which is exactly the problem with the void that doesn't play by these rules. Level 5. An uncompensated void is a gap where the missing mass isn't balanced nearby. No sufficiently dense rim closes the account. The underdensity extends further than the surrounding structure can make up for, meaning the region's average density stays measurably below the cosmic mean even when you zoom out. This isn't just a bookkeeping curiosity. Light passing through an underdense region loses a small amount of energy through the integrated Sachs-Wolf effect, arriving very slightly cooler than it should. Compensated voids largely cancel this signal out since the dense rim on the way back out roughly offsets the energy lost crossing the empty middle. Uncompensated ones don't get that cancellation, and the cooling signal survives all the way to our telescopes. Some researchers have pointed to exactly this kind of imbalance as a possible explanation behind the CMB cold spot, an anomalously cool patch found in the universe's oldest light in 2004, potentially tied to a supervoid in the direction of Eridanus. A 2008 stacking study of dozens of known supervoids and superclusters even reported a combined ISW signal stronger than standard cosmological models predicted, which is either a hint that some of these regions are more uncompensated than expected, or a statistical fluke amplified by how the sample was selected. Other later studies argue the effect measured there is weaker or entirely absent once different methods are applied, keeping the debate very much unresolved. An uncompensated void, in other words, is a gap the universe never quite settled its accounts on. And once you accept that voids can behave like that individually, a strange question follows. What happens when voids start interacting with each other directly? Level 6. According to the hierarchical model of void evolution, first formalized by researchers Scheth and van de Wegert, in 2004, voids don't just sit still once formed. They grow, and the mechanism is almost unsettling once you picture it. A smaller void sitting near the edge of a larger one gets absorbed as the bigger void's boundary expands outward over time, merging the two into a single larger emptiness, nothing consuming nothing. This is, in effect, how mini-voids and supervoids are connected across cosmic time. The smallest gaps from level 1 aren't a separate population from the supervoids in level 3. Many of them are simply earlier stages of the same process, still waiting their turn to be swallowed by whatever larger void happens to be expanding nearby. Give the process enough billions of years and small voids feed the growth of the very large ones we've spent this entire explanation marveling at. Simulations of this merging process show void networks slowly coarsening over cosmic time, the way foam bubbles in a glass merge into fewer, larger bubbles the longer you leave it standing. Fewer voids, each one bigger and emptier than before, is the long-term trend the mathematics predicts. Run this process across the full age of the universe, and it starts to look less like a side detail and more like a life cycle. A mini-void from level 1 isn't guaranteed to stay a mini-void. Given enough time and the right neighbors, it graduates, merging its way toward regional status like the local void, and eventually towards supervoid territory like booties. The categories on this list aren't fixed boxes. They're checkpoints along the same road, and every void currently classified as small is, in theory, just a supervoid that hasn't finished growing yet. It sounds like an unstoppable trend. Emptiness endlessly consuming emptiness, growing bigger with nothing capable of stopping it. Except that isn't quite true. There's a mirror process, and it works in exactly the opposite direction. Level 7. Scheth and van de Weygart described a second fate for small voids in that same framework, one considerably harsher than merging into something larger. A void in cloud is a small void that happens to form inside a much larger region destined to collapse under its own gravity into a dense cluster or supercluster. As that surrounding cloud contracts, it doesn't just leave the small void alone inside it. The collapsing structure squeezes inward from every direction, and the void gets crushed, its underdense pocket erased as the walls around it close in and convert what was empty space into part of the very structure it once sat inside. Nothing survives, it gets overwritten. There's something almost cruel about the timing of it. A void in cloud doesn't get crushed because it did anything differently from its neighbors. It formed in a location that, purely by chance, happened to sit inside the gravitational reach of a much larger collapse already underway. Two voids can begin as nearly identical patches of low density and end up with completely opposite fates, one merging its way up through every level on this list, the other quietly squeezed out of the picture before it ever gets the chance. The geometry of what's forming around a void, not the void itself, decides which future it gets. Erased, not shrunk, not weakened. Overwritten, as if it had never been there at all. The last stop for a void that started out looking exactly like every other one on this list.